Hi students, now we will discuss another problem, another Lagrange's linear equation by using the method of multipliers or by method of grouping or in both. By using both, how can we solve a Lagrange's linear equation which is of the form capital P into small p plus capital Q into small q is equal to R. Okay, so this is the problem. Solve p small p into x into z minus 2y square is equal to z minus qy into z minus y square minus 2xq. Okay, so now this is the given equation. Now I am rewriting this. This is not exactly in the form of Lagrange's linear equation. Okay, you can see this is not exactly in the Lagrange's linear equation, but here you can see the p and the q we have, and the degrees of small p and the small q is 1. So definitely it's a linear equation. Okay, it's a linear equation. So I think you already know about the linear and the non-linear equations differences. Okay, this is a linear equation. Now rewriting this equation, okay, like this here in the Lagrange's linear form. Okay, so that is x into z minus 2y square into small p plus y into z minus y square minus 2x cube into small q is equal to z into z minus y square minus 2x cube. That is, which is of the form capital P into small p plus capital Q into small q is equal to R. Okay, you got this, which is of the form capital P into small p plus capital Q into small q is equal to R, which is the Lagrange's linear equation. Okay, now right here this what are the auxiliary equations? The auxiliary equations are dx by capital P is equal to dy by capital Q is equal to dz by capital R. Okay, now here you can see since capital P is equal to this and capital Q is equal to this and capital R is equal to this one. Okay, so now taking the second and the third members. So whether we can let us check, observe these auxiliary equations, whether we can solve, okay, whether we can solve these equations by taking grouping or taking multipliers. First check whether we can solve these equations by grouping. Just by taking any two members, that is by grouping, can be solved or not. Okay, so take these two. So if you observe these two, you can cancel this, and the dy coefficient is y, the dz coefficient is z. Okay, so now we can solve and we can get one independent solution by grouping. So that's what now we are going to do here. Okay, so see this dy by y into z minus y square minus 2x cube, dz by z into z minus y square minus 2x cube. Okay, so now same terms you can cancel, dy by y is equal to dz by z. Now integrating, okay, so I told you whenever we integrate this one, the dz coefficient must be a function of z. That may be 1 by y or y square, like that, and dz 1 by z, z or z square, or any constants also, not a problem. Okay, now integrating we get, what is the integral of 1 by y? Log y. Integral of 1 by z? Log z, plus log a is an integral constant. Okay, now see this, a log y minus log z is equal to log a. Okay, so now log a minus log b can be written as log a by b, yeah, is equal to log a. So both sides the logarithms you can cancel, and therefore this is the first independent solution. Y by z is equal to a is the first independent solution. You can check this. This is the first independent solution. Now we need to find the two solutions. Okay, two independent solutions. We got the one. Now let us check the another. Okay, let us check the another one now here. So for that, so now if you observe this, can we go with again grouping? No, we cannot get the another independent solution by grouping. For that, what we have to do? Let us go with the multipliers. Yeah, let's go with the multipliers. How to choose the multipliers? I think we already discussed, yeah, in the last videos. You have to consider that multipliers L, M, N, so that LP plus MQ plus NR is equal to 0. Or if that is also not possible, make sure you multiply this one taking any these 2 or these two, okay, in the denominator, okay, the derivative of the denominator exists in the numerator, like something dx minus dy by x minus y, okay, so like that, dx plus dy by x plus y. In such a way we can choose the multipliers, okay. So now in that process, now we can let us go with whether we can take the multipliers. See, this again each ratio of now I am rewriting that 1 equation 1 like this, yeah, equation 1 like this, just by dividing entire equations. I am writing like this: z minus y square minus 2x cube by x into z minus 2y square. What I did, just multiplied the entire equation with z minus y square minus 2x cube. What happened here? Both terms get cancelled. dy by y is equal to dz by z. Now just by rewriting like this, now it is easy for us to choose the multipliers, okay. Now using multipliers, L is equal to 1, M is equal to 2xy, and N is equal to minus x, okay. Now choose the multipliers here. L is equal to 1, M is equal to 2xy, and N is equal to minus x. Okay, so now by taking that, here you can observe this. Each ratio, after taking the multipliers like that, we are getting the denominator. Here the 0 it is, okay. Z is z minus y square minus 2x cube into dx plus 2xy into dy minus x dz. So take that 0 to this side, this will be 0, okay. So LP plus MQ plus NR is equal to 0. That means L dx plus M dy plus N dz is equal to 0. So simply you know that, okay. Whenever that LP plus MQ plus NR is equal to 0, simply remember L into dx plus M dy plus N dz is equal to 0, okay. Now here we got this. These are the terms, and I am rewriting this one as a z dx minus x dz, combining these two, z dx minus x dz. Next, minus y square dx minus 2x cube dx, and here plus 2xy dy, okay. Now again rewriting this z dx minus x dz as it is. Now I am writing here this 2xy dy as, okay, 2xy dy as x into 2y dy, this term x into 2y dy, and minus y square dx, okay, and here this is minus 2x cube dx. Now what I am doing, dividing by x square, okay, dividing by x square, we get entire, just divide by x square, z dx minus x dx by x square, and this one also x into 2y dy minus y square dx by x square minus 2x dx, okay. Now you can observe this one, this can be written as a differential of, by taking the minus common, this can be written as a derivative of z by x, okay, just like a derivative of u by v form. Similarly, this term, this one can be written as differential of or derivative of y square by x, minus 2x dx can be written as derivative of x square, okay. All the three terms here like this combined ones here, this can be written as derivative of z by x, and this one derivative of y square by x, derivative of x square. Now you can integrate this directly to get the solution. The derivative and the integration both get cancelled here. It remains minus z by x plus y square by x minus x square is equal to the integral constant b. So therefore now from 2 and 3, you can observe that from 2 and 3, the general solution is phi of y by z comma y square by x minus z by x minus x square is equal to 0. Okay, so this is the required solution of the given problem. It's very important and little complicated. Okay, just you need to concentrate more on this one and try to understand this and follow and practice, and you will be perfect in solving the another problems also. Okay, I hope you understand this problem. Thank you.